Good afternoon, one and all present here. I am Joseph, the head of the competitive programming team of the SSN Coding Club. So it is a pleasure to invite Dr. Neeldhara here to give us a talk on algorithmic puzzles, which is the heart of competitive programming. Dr. Neeldhara is a Srimati Amba and Sri V.S. Sastry Chair Associate Professor of Computer Science and Engineering at the Indian Institute of Gandhinagar. She completed her PhD from the Institute for Mathematical Sciences in 2012 in theoretical computer science. Her research interests include the design and analysis of algorithms and computational social choice. She is also interested in visualizations and other methods to communicate computational thinking at an elementary level. She also enjoys learning about new card tricks, especially self-working ones, even though she can't remember any. So through this talk, we sincerely hope that you will gain a better understanding of competitive programming and maybe even choose to pursue it further. Now I invite Dr. Neeldhara to take the floor.
All right, thank you so much. Appreciate the introduction and thank you for having me. It's a pleasure to be here. And so thanks to you and the Competitive Programming Club at SSN and Chitra for having me. Let me just full screen these slides and hopefully you see the slides in full screen at this point. And yeah, I mean, I'm not a competitive programmer. I'm sure most of you in the audience, if you're already into competitive programming, then you probably know more about it than I do for sure. I'm a hobbyist competitive programmer in the sense that I really enjoy reading puzzles that come up or questions that come up on these platforms, and I've enjoyed sort of I think when I started out, I did not like it so much because of all the time pressure and the fact that you had to do things quickly. And I'm generally speaking very slow at just even reading and understanding what is going on, let alone solving it, which is like a whole other sort of process. And there's a lot of luck involved in getting the right idea. And I never really trained for it formally. So I wasn't, I think when I was in college at your sort of stage of life, like I was totally oblivious to competitive programming. As in, I didn't know anything about it. I didn't want to know very much about it because in school I'd heard about the Olympiads and I did not like the format at all. So it's only much later in life that I've come to sort of warm up to the idea that, you can still enjoy the process of solving these problems without having to feel like without having to feel the sort of the pressure of doing it in a short amount of time. But of course, for most of you, you probably find it exciting that you have to compete and you have to sort of get things done quickly. So for many people, a lot of the adrenaline rush comes from that. So if you enjoy that aspect of it, more power to you. Enjoy it for sure. So I'm not completely sure how the audience is like divided. Like, are most of you already experienced with competitive programming, or are most of you thinking about whether you want to start your competitive programming journey or not? This is primarily intended as an introduction for people who are in the latter category, but I also hope that those of you who have been into competitive programming for some time will also find some takeaways from this talk. So first of all, let me talk about the popular CP platforms. I think if I was there in person, I would just like do a survey of the room, like do a show of hands. How many of you have heard of this? How many of you have heard of that? And so on. But it may not be very feasible in this format. So I'll just go ahead and keep this like a monologue. By the way, if it ever gets boring, feel free to interrupt at any point with any questions or comments that you have. Okay. So I think one of the oldest platforms for competitive programming was Topcoder, and Topcoder is still active now, but they're branched out into many different things apart from algorithmic coding competitions. So they still do algorithmic contests in many formats. They do it in timed formats. They do it in marathon formats where it goes on for a while longer and things like that. Um, Now I think they also do design contests and bug fixing contests, and they do just many other things. And I don't know if maybe many of you are too young to know when Topcoder started out, but when they started out, it used to be like this, you know um, Java applet that you had to download and run, and they would only support C# and Java and C++, I think. More recently, because of the growing popularity of Python, they also support Python. But so they used to have, they still have what are called single round matches, which happen very regularly, and there are two divisions. And if you're starting out, I think you start out in Division Two, and then you progress slowly towards Division One once you want to be competing with the more experienced coders on the platform. And I think Top Coder probably started this whole culture of ratings being colored. So everybody wanted to be a red coder on Top Coder, because that sort of showed that you were in the top whatever percentile, and that brought you a lot of fame and glory in this sort of community. And they had, and they still have, very active discussions Discord server. So if you haven't checked that out, you should. It's a nice community of people interested in competitive programming. Um, Also, they have like very nice resources in terms of just training materials. So many people learned their, dynamic programming and graph algorithms and so on just from the Top Coder website, because the nice thing was that they would explain the concept very succinctly. It's different from reading a textbook, because usually they would skip the details of the proofs and things like that and really tell you what mattered, which is the mechanics of the implementation and what is the time complexity. And that's really all that was important to just get going, right? So if you were interested, you could look up the proofs elsewhere. Or sometimes, depending on who's writing the tutorial, they would explain the proofs a little bit more, but usually in a very accessible way. But the crucial thing was they would give you pointers to practice problems. So it was nice to, just nice to immediately practice your skills after you've learned a particular technique. But these days, most experienced coders will tell you that you should not practice topic wise, because it biases you. So you should probably just go and practice in contests after reading up on a bunch of topics. So we'll come back to like how to train a little bit later, but it's just a little bit of history. Top Coder was where it all started. They had the Top Coder Open, the TCO, which is sort of a contest that has many rounds, and finally it all culminates in sort of this physical contest. It's really like watching a sport. There would be commentators describing the problems, describing what's going on the leaderboard, who is leading, who is winning and losing. And it's all very exciting for people who are a part of that community and who know, I think just like in any other sport, the top players in some sense have their own sort of people who follow them, admire them, and so on, and they want to see them do well and win and so on. So I think Top Coders started a lot of this frenzy, and they're very much still around. But I think a few other platforms have come in and have also gained a lot of popularity. If you are already on these or aware of these are great platforms for practice. So Spot is like the Sphere online judge, and it actually, at the back end, the Sphere judge actually powers a lot of the other coding platforms as well, including platforms like even CodeChef, I think, until recently, at least, as far as I know. And UVA also has a whole bunch of practice problems from different sources. And the reason I like UVA is that I think there is another website that goes with it called UDebug. And UDebug gives you a lot of test cases and things like that for many of the problems on the UVA platform, other platforms as well, but definitely for problems on UVA. So it's very useful if you want to just you want an additional resource for, because often when you're stuck with a problem, at some point, okay, sorry about that. At some point, you can't figure out what tests will break your code and things like that. So you have to maybe get some additional help. So on some platforms, you can actually get tests, and I'll talk about those in a bit. But on some platforms, you don't have access to tests except for the small ones that come with the problem description. So UDebug is a community-driven resource where people contribute tests and the sample answers so that you can, it'll help you with debugging your code. Speaking of debugging, Topcoder was also one of the earliest platforms to make debugging actually a task. So they would have, I don't remember what it's called anymore, but they would have like a 24-hour challenge phase, I think, where they would actually open up all the submissions to the contest. So you could read what other people have submitted. And if you believe that somebody has a wrong solution, then you could actually challenge it with a test, which you're confident will sort of break the problem. And again, okay, sorry about that. I think I should probably put my phone on silent. Yeah, so right. So what I was saying is that that's a very interesting exercise because it forces you to get good at reading other people's code. Although I should say that on competitive programming platforms, it's a complete pain to read code written by other people, probably also yourself, because you're just trying to get code working in a very small amount of time. So you're not concerned about things like, good variable naming conventions or good indentation or all of that. You just want to get something that works. So it's very painful to often figure out what a piece of code is doing. And with the top coder challenge phase, you really ended up getting good at that because of the incentive to get some extra bonus points by finding out problems with other people's submissions. And that's a good skill for yourself too, right? Because like they say, when you're playing chess, you're typically analyzing the game from your perspective, but it's very useful to also know how to analyze the game from somebody else's perspective. Here, the more you learn about how to read other people's code, it also makes you more efficient at finding and fixing bugs in your own code. So that's, I think, a very interesting aspect of top coder challenges. Like I said, other platforms came and started gaining popularity. Google Code Jam was, again, one of the older ones. I think they go back well over a decade now. I think when it happened the first time, I don't remember, they probably had like 10, 20,000 people participating. And it's again something that culminates in a physical contest. So usually registrations open around March. So if you're interested, you should definitely mark your calendars and look out for the next Google Code Jam. They have a qualifier round which runs for 24 hours. So there's no time pressure. You can take your time, solve the problems. And they usually have the qualifiers are just to test that you know how to program. The questions are usually very simple, but they use the qualifiers to put one or two interesting questions. It's like very unusual. So I'll show you a couple of examples later in this talk. But yeah, there's a 24-hour open qualification round. If you have done your first programming course and you've done data structures, then you can probably do qualifiers without any additional preparation. But that qualifies you for round one, which happens 3 times. So you have 3 chances to make it to the top 1,000 from each of the round 1A, 1B, 1C advances to round two. Then I think the top 3,000 altogether compete for the next 1,000. And from there, they shortlist, I believe, 25 people or something like that for the main event, which again happens at Google headquarters somewhere, typically in the US. And again, it's kind of a big deal, gets, live streamed on YouTube, and people are usually explaining the problems, seeing how people are doing. It's very fun. And you if you're in the community, you kind of know the people who are doing well in these contests, and you support your favorite contestant, I guess. Or you might be in the race yourself, so you might want to be sort of preparing for the GCJ finals. You might find yourself preparing for them this year, next year, whatever. Good thing is you have plenty of time. So by the way, I should say that so far all the contests I've mentioned are open to everyone. So you don't have to be in college, or you don't have to meet a certain age limit to actually compete. But the next ones, okay, I should say that Kickstart is, I think, after the serious popularity of CodeJam, I think Google started doing Kickstart, which is like, I think they run multiple contests a year, so you don't have to wait till March to compete. So Kickstart is typically happening all year round. The next deadline's probably like 1 or 2 months away, so you can watch out for Kickstart problems. So all the Google contests problems are designed by Googlers on their 20% time, the time that the company says you can do whatever you want, and these are therefore typically very clever people behind these problems, and they often have a sense of humor. So the problems are really interesting to read, and the analysis is really well done most of the time. So really high quality problems on this platform. Unlike the ones we have talked about so far, the Olympiad and the ICPC are age-limited contests. So Olympiad is for people in school, ICPC is for people like you in college. And again, they have a whole regional, zonal, national, international kind of structure. It's kind of complicated. And you can find out more by just going to the sort of respective websites. Although you may not be eligible for writing Olympiads anymore, I think the Olympiad websites, the past contests are again great resources for practice. So that's why I mention it here. Of course, these are the more, I think, de facto popular platforms right now, platforms like Codeforces, CodeChef, AdCoder, Russian, Indian, Japanese platforms for practicing. And all of them have pretty regular contests, once or twice a month in different formats. CodeChef is probably the only platform that runs long challenges, so you can take your time to solve the problems. They all have a very similar structure where there are multiple divisions based on your level of experience. They have ratings similar to Top Coder. They have colored ratings, so you want to work your way up the ladder over time. That's usually the idea. um, Apart from these, what I think of as traditional algorithms, competitive programming platforms, there's also other competition platforms that allow you to sort of practice computer science uh, ideas. So if you're into machine learning, you like working with data sets and things like that, you've probably heard of Kaggle, which is a very famous platform for doing interesting things with large data sets. CTF has captured the flag contest. So if you're into cybersecurity and things like that, you should probably look out for, it's a style of competition. Many organizations come up with these contests, usually involves, a lot of interesting puzzle solving. You okay, so it's hard for me to describe. Also, I have never really participated, but you should definitely find out more if you're interested in cybersecurity, crypto, and that sort of thing. Also, a lot of research conferences have contests associated with them. So, for instance, satisfiability, which may be a problem that you have heard of if you have done your second algorithms course and you've seen NP-completeness. You've probably encountered satisfiability as like the first NP-complete problem. And the SAT challenge has been ongoing for several years now. The idea is to come up with SAT solvers that beat the current benchmarks, do something new and interesting. And it's amazing that they attract a lot of interesting submissions every year. And SAT solvers have just been getting better and better over the years. So it's increasingly challenging. But it's if you're a little bit research oriented, you should probably look up some of these contests. So the PACE contest also is a more recent one. I think it's going to be in its fifth or sixth edition now. And, again, these are typically long form contests. You can take your time. It happens over several months. And instructions and data sets are released at a certain point of time. And there is a deadline. And there's usually several weeks or months between them. So yeah, this whole community broadly identifies people doing algorithms engineering, and a lot of the skills that you pick up from competitive programming are quite easily transferable to this research algorithms engineering setting. The only thing to be careful about is, the small things like when you're writing for a research community, you want your code to be easily readable, maintainable, and so on. So you want to be careful about ensuring that you don't follow some of the bad habits that you may have picked up while training for CP contests. Okay, so I will share a link to these slides, so where you can find pointers to all of these platforms that I've mentioned here, and I hope you find something that interests you. There's a whole spectrum. It doesn't always have to be algorithms, and it doesn't also always have to be like a timed competition. There are a lot of competitive formats out there which give you more time to really think through things and implement solutions to hard problems. Okay. All right, so this is just for some context. I think there's a lot of discussion in college circles that I hear all the time about DSA versus competitive coding versus, um, where should you spend your time? Should you do development? Should you do CP and so on? And those are very common questions that come up. And a lot of people pick up CP because they think it'll help them with placement interviews, which may be true. But this is a comment from Mahdi, who is a theoretical computer scientist. And you might again know that P versus NP is probably the most famous open problem in computer science of all time. And he says he would still prefer to pick that up as a challenge compared to doing well in something like ICPC or the Olympiads and so on. And it's probably a bit of a tongue-in-cheek remark, but this goes to show that, yeah, I mean, CP is hard, okay? And, if you're in it just because you want to clear, I shouldn't say just, but if you're in it because you want to clear placement interviews or something like that, there's probably less painful ways of preparing for interviews. You don't have to, do necessarily CP to be well prepared for interviews, if that's the only goal. Of course, a lot of people start out like that, but then they sort of get the hang of CP and they start enjoying it, and for completely independent reasons. So if that's you, that's great. But you don't have to feel obliged to do CP just because everyone else is doing it, and neither is it the most optimal way of preparing for placements. You want to prepare for placements. There are a lot of resources these days that help you systematically do that. And as long as you have your data structures, algorithms, basics down, and you have some practice with implementations, that should really be enough usually. If you do CP, of course, placement interview preparation becomes a lot easier, but it's like bringing a big hammer for a small nail, if that makes sense. So okay, so with that sort of disclaimer out of the way, hopefully you're doing something like CP for the right reasons. I wanted to give you just like spend the rest of my time divided in two parts. One is just giving you an introduction to like the anatomy of a typical CP problem and how the whole thing works if you want to get started, and the other is just talking about intersections between CP and computer science research. What kinds of things can you do once you have outgrown, doing contests on a regular basis. So, okay, so let me talk about the anatomy of a typical problem. Every contest problem usually has a problem statement, and sometimes it's very dry and it just tells you this is what needs to be done. But sometimes, and this is very, very common in CP, it's almost a cultural thing, that sometimes the whole task is wrapped around some completely crazy story. So you can see here, this is a problem from one of the Google Code Jam contests from a long time ago. And like I said, the Googlers who prepare these contests usually have a sense of humor. So you can even see in the language that it's very amusing. So Goro has 4 arms. Goro is very strong. You don't mess with Goro and so on. So even has things like algorithms are not Goro's strength. Strength is Goro's strength. Probably really written by somebody who wanted to be a stand-up comic but ended up in the wrong profession. So anyway, so this is a really fun problem actually. It's a sorting problem where essentially you're trying to sort the array by randomly permuting the elements, but you can ensure that some elements stay in place. Okay, so you get to choose which elements you want to fix and which elements you want to randomly permute, and you assume that you can intelligently fix which elements you want to stay in there. You want that they have to stay in their positions. So you can, the question here is to determine, on an average, how many times do you need to actually permute the elements before the array is sorted. So, so yes, so that's essentially, so, okay, so you can see here that the question is asking for the average number of hits, for sorting the whole array. You have to assume that when the table is hit, the unfrozen elements are permuted uniformly at random, and because this is inherently a randomized algorithm, you can only ask questions in expectation. So you cannot deterministically say that, okay, it'll definitely get sorted in so many steps, but the question is what happens in expectation. So this is This is the first thing that you read. It's a problem statement, and typically you have more information about the format of the input and the output. And the crucial thing is this information about the limits or the constraints. So you get to know how big or small the test data is going to be. And CodeJam and some other platforms give you this sort of segregated data sets where you'll get some partial credit for solving the smaller data sets and full credit for solving the larger one. So usually the assumption is that the processor, the judge that is going to run your code can execute something like 10 raised to 9 operations per second. So usually the time limit is something like 1 or 2 seconds. Again, depending on the platform, sometimes you may get a time relaxation if you're using a language like Python, which is known to be a bit slower than, say, C++ or Java. So sometimes these platforms will give you like a 4x time relaxation if you're using Python. But the point is that you can usually look at the size of the data set and reverse engineer how much time your algorithm can take. Okay, so for instance, if n is at most 1000, as it is here, your algorithm can probably take n squared time, and it should be fine. But if n is something like 10 raised to 9, then even n log n time is kind of going to be dicey. It's probably going to be that's usually a hint that your algorithm should run in linear time. So usually you can look at the range of the values in the data set and quickly get a ballpark estimate of what you should aim for in terms of the running time of your algorithm. Sometimes the data sets are kind of liberal in the sense that they're easy. Even though there is a linear time algorithm, the data set will allow for n squared time algorithm. So that's one way that problem setters make a problem easier if they want to do that. But usually if uh, usually the target is to find the best possible algorithm for a given problem. Okay, I mean, sometimes the problem setters may miss an even better approach than what they had in mind, but that is usually very rare. So usually you're looking for the most optimal way to solve a problem. You can generally assume that. So apart from the limits, which is a very, very crucial piece of information in the whole problem statement, you also have some sample input output. And if you're lucky, the problem setter would have given you some explanation for why the sample input output works the way it does. So in this case, you have some information here. And you can imagine that the small data set is small enough that you can probably try to do things like just simulating the process and seeing what happens and computing the average. But so usually what happens is that for the smaller data sets, some version of brute force or slightly intelligent brute force with some with a little bit of cleverness will be enough. Okay, but then you have to think of something really interesting for the larger data set to go through. That's usually how it is structured. So this is an explanation of the sample input and output. Now, for the older problems on most platforms, you will usually have some kind of an editorial, as it's called in CodeChef and Codeforces. On Google CodeJam, it's called the analysis. And in the analysis, they will actually explain what is going on, right? And what's the answer? How do you solve it? And sometimes the analysis will even have actual code from the setter or the tester, and you can usually access the solutions. So it's one of the difficult questions when you're preparing for competitive programming is, at what point do you give up? So I should have put a spoiler alert here, so let me not show you the solution too much in case you want to think about this problem yourself. But when you're practicing or up solving, as some people call it, after a contest, if you didn't get some problems, you just continue solving even after the contest is over and try to figure it out later. It's good for your practice, but I guess one of the issues is at what point do you give up and say that, okay, I just want to look at the solution. And this is a hard one because you don't want to give up too early, but you also don't want to be struggling for too long, because that's time that you could be spending on the next problem or learning a new technique. So you have to find what's the right balance for you. And this is where preparing in a group really really helps, because then hopefully you can talk to somebody who has solved the problem and to whom you can explain what you have tried so far, why did it work. And then this person, unlike a static editorial, can actually give you smart hints without completely spoiling the solution. So I definitely recommend getting into a study group for, for practice. Okay, so in this case, it turns out that this problem is actually fairly mathematical, and in terms of code, it's just like it's very very simple. It's probably like a you just have to. Okay, so I don't think I want to tell you what you want to compute, because that'll be a bit of a spoiler. But the code is really just like 3-4 lines of code to determine the answer. But to be sure that that is in fact the answer, you do need a proof and like a proper argument. And I will say that most people in the middle of a contest will not worry about writing down a formal proof, as long as you have a gut feeling and you have some intuition that this is probably correct, and you have some reasoning in your mind that you feel is enough, you just go ahead and do it. But I would definitely recommend, once the time pressure is off, to come back and actually convince yourself formally why something works. It's very easy to be in a situation where you're completely convinced that a certain approach is correct, but it is in fact not. And so there, being having the skill of being able to quickly verify at some level of certainty that this actually works is a really useful skill. And it'll also allow you to find bugs when your approaches are not wrong, so that you can go and correct your approaches. And that you need to be able to do quickly. But ultimately, there will be many situations where you have written some code, it passes all the tests, and you don't have like a completely let's say a mathematically sound argument about why it works. You just have a feeling for why it works. So I would definitely recommend coming back and trying to write down a little bit of an argument, so that you're really convinced that it's not just some it's not just some luck by chance kind of a solution, but that you actually know why it works, because that's I think a really important part of the process. But I completely understand that that's probably not the smartest thing to do during the contest, unless your code is failing and then you need to find why it's failing. Then of course you need to think from the point of view of correctness, but you don't have to write like a mathematical proof on pen and paper before you code up the solution during a contest. That's not the best use of your time. But I'd say after the contest, whether you write it down or do it some other way, just really make sure you understand why your approaches actually work on all cases, right? Okay, so here's another nice problem that if you want, you can try it yourself. This is, I don't remember if this came in a qualifier or a round one, again from Google Code Jam. But the reason I'm highlighting this example is just to show how unusual code jam problems can be. So this is not, it doesn't happen very often, but they do often throw in like problems in non-standard formats. So of course, a lot of platforms these days so also do interactive problems. So normally what happens is you have an input and you have an output, and your program's output should match the judge's output on every input. That's usually the way this works. Okay, so um, you have a task, you know what needs to be done, and you do it deterministically, in the sense that your solutions always have to work on all instances, and the way it is tested is through these exact matches. Okay, but sometimes the input is interactive, in the sense that you can go back and forth with the judge. You say something, the judge returns something, and then you say something more based on what was returned. So that is one variation that's becoming increasingly common. But this is unusual one, because this was actually asking, in some sense, for a solution that was not deterministic. Okay, so let me just quickly tell you about the problem. I think it's just, the first time I saw it, I thought it was very counterintuitive that something like this could even be done. But now that, almost everybody is learning about machine learning and classifiers and so on, maybe you don't find it that crazy. But when I saw it first, I was like, my mind was blown. But anyway, so here is the problem. The problem says that I'm going to give you two algorithms for generating a random permutation. So here is a first algorithm. You start with the identity permutation, and then you have this for loop, which basically says that I'll go through the whole array, and when I'm at the kth location in the array, I will find some later element at random to swap the current element with. So of course, if P happens to be K, then there's no swapping that happens. But otherwise, you could end up with a random swap, right? So that's one way of generating a random permutation. And of course, you could ask yourself, does this generate every permutation uniformly at random and so on? Like, what is the probability for a specific permutation to show up and so on? Now, here is another algorithm which may look very similar to the one before, but notice that there's a small difference, which is that when you're randomly choosing an integer, when you are at the kth location in the array, you don't choose it from afterwards. It could be any location in the array. That's the only difference between these two algorithms. Okay. So they call this, for some reason that I will not get into now, for some reason, they call this the bad algorithm. And the algorithm that was shown before, they call it the good algorithm. So there are two algorithms, a good algorithm and a bad algorithm for generating a permutation. Now the input to this problem is a permutation that was generated using the following process. So first a coin is tossed. If the coin is heads, you generate a permutation using the good algorithm. If the coin comes up tails, then you generate the permutation using the bad algorithm. Okay, so the permutation was generated using one of these algorithms. Which algorithm was used was chosen with equal probability. Your code should take this permutation as input and figure out if it was generated using the good algorithm or the bad algorithm. Just by looking at the permutation, you don't have any other additional sort of information. So to me, it was very crazy that you could actually do this. And of course, they're not looking for a deterministic answer because it's more or less impossible to do this correctly all the time. But what they are hoping for, or what they're asking for you to find, is to be able to write an algorithm that is able to correctly guess which algorithm was used most of the time. Okay, so I think you don't have to get all the answers correct. Your solution would be considered correct if your answers for at least 109 cases out of 120 are correct. Okay, so that's the deal. Again, I don't even have screenshots from the solution. I think I just have screenshots about the format, which is a very straightforward format, but you really have to think a little bit about, how do you correctly guess with high probability just by looking at the permutation which algorithm was used to generate it. So this is one of my sort of favorite problems from CodeJam. I think I learned a lot just thinking about it, looking at the analysis and so on. And I think it's a good exercise to go back and try. Even CodeJam does not have a lot of randomized problems even now, I think, but they throw in problems every once in a while where the format is a bit unusual, or there's something weird going on, and so it kind of breaks tradition. And I think if you enjoy puzzles at large and you're not just looking to quickly pattern match this with something that you already know, I think you'll really enjoy the core jam problems. Especially, I mean, all platforms are really nice, but I think if you have a thing for clever, sometimes funnily worded puzzles, I would definitely recommend CodeJam, simply because I've spent more time looking at their archives than most of the other resources I mentioned. Okay, so now in the last part of this talk, let me tell you a little bit about ties between competitive programming and computer science research. So there are many ways in which these two worlds kind of overlap. So for instance, there's a lot of research on rating and ranking systems, which is foundational to competitive programming. You want to find fair ways of coming up with ratings. I don't know if you've ever wondered how those deltas change from contest to contest, how your performance in a contest, sometimes you may feel that, oh, I performed okay, why did my rating go down so much, or why did it go up only so little, and so on. So these sort of formulas that are used to calculate your ratings, and just making sure that that's the ratings actually reflect people's abilities. That is something that people kind of study all the time, just not just in competitive programming, also for other games like chess. And making fair rules for games is just, it's a whole field on its own right. Okay, so that's one sort of thing. Sometimes competitive programming problems are great examples for showing off language features. So if you're into programming language design and you've come up with a new language, or you're studying a new language and you want to talk about, using a slightly esoteric language or a language with a very specific feature set to solve certain kinds of problems. Usually, CP problem sets are great sort of databases for doing this, right? The problems themselves sometimes lead to new research, or sometimes new research actually comes into the CP community and gets used. And of course, it's also used in CS education research. So let me just give you like quick samples from each of these. So for example, this is a thesis from 2009 about theoretical and practical aspects of programming contest ratings. And if you look at the bibliography in this thesis, you will find a lot of related work on both programming contest ratings, but as well as ratings and rankings and other kinds of competition. So this is an example of the first kind. In terms of the problems themselves, I think this is a screenshot from a paper on Archive. It's like it's again a theoretical computer science algorithms kind of a paper, and you'll see that there is a reference, and that reference, there's a reference next to this phrase using a trick of G and probably others. So this reference is to a Code Forces blog post, and if you go to the blog post, you will see that they have also linked back to the paper. So this was a problem about range queries. I will not have the time to actually give you additional context on the problem, but if you want, you can go and look this up if you're curious. But yeah, this was a relatively recent paper, I think, from last year, and so this kind of this back and forth that sort of happens. Recently, there was a massive breakthrough on the best running time you can achieve for max flows. And you might know that max flows is, again, a technique that comes up in competitive programming quite a bit of the time. And I think one of the authors on the max flow breakthrough was also an active competitive programmer. And there was a nice discussion on Code Forces, on one of the Code Forces blogs, about whether we should be using this new algorithm in contests. And as far as I remember, I think the recommendation from one of the authors was that it's probably not suitable for contests, in the sense that the improvement that you get in performance is not worth the complication that is involved when you actually write the code. So anyway, that's another example of how, like, CP, people who are good at CP often do go on to become researchers of algorithms or in other fields of computer science, and they usually don't like completely drop out of CP. Some people do, some people just like move on, but some people continue to compete, or if not compete, they remain engaged with the community. So there's usually a lot of interesting sort of knowledge sharing that kind of happens. This is another example. I have to double check the year, but this is a paper that appeared in a conference called Fun with Algorithms. And this is coming from ICPC coach who was training with their team, and they found an interesting problem on Code Forces called counting circles without computing them. And like, this is a nice short paper. It's reads like an expanded editorial, but some really interesting ideas for how to solve this problem even faster than the currently best submission that's there right now. So I thought that was an interesting paper as well. Coming back to examples of like showing off programming language features, there's this language called PCAT, which is logic-based constraint programming language. So it lets you express yourself in terms of constraints and optimizing certain functions relative to those constraints and so on. So yeah, logic-based language is kind of a certain family of languages. So I think to illustrate the usefulness of PICART, or the fact that it can be used for certain kinds of generalized problem solving, they actually solved many Google Code Jam problems in this language. And there are, I think by now, multiple, well, there's certainly at least one, but I think there are multiple manuscripts or papers that actually describe PICART-based solutions for Google Code Jam problems. So by the way, disclaimer, I'm not even sure if I'm pronouncing the name of this language correctly, but I would say that the papers, nevertheless, are totally worth checking out if you're interested in this sort of thing, in learning new languages or seeing how other non-standard programming languages work. And the way they solve these problems using this language also, it's interesting that if the language mechanics allow for certain constructs, then it leads you to thinking about the problem in different ways as well. So you'll find that some of these problems, the way they're solved, is slightly different from the standard solutions that are there in the editorials for these problems. So that's one more example. I talked about competitive programming in CS education research. To be honest, I haven't seen very directly CP problems featuring in CS education research. I've seen papers about how to generate puzzles using AI ML techniques and so on, but I thought it could be directly relevant for systems like these. So let me just quickly tell you about this is research from a group at Brown University. So they have this system called Exemplar, which is sort of a IDE. So this interface may look familiar if you've been coding on Replit or VS Code or whatever. Usually you're writing your code on the left and you have some output on the right and so on. So usually, even in a DSA course, when you're doing lab problems or whatever, usually what you are given as the exercise is the problem statement, just like we saw, and you're given some tests and you are supposed to write code that passes all the tests. Now, in Exemplar, this whole thing is kind of reversed and turned upside down. So what you are given is a problem, but you're also given solutions. Okay, so you're also given multiple solutions to the problem, most of which are wrong. Okay, they have some small bug, or they're solving a different version of the problem. There's some misconception or whatever. So there are all of these different solutions, and your goal in this exercise is not to write another program to solve the problem, but it's to come up with tests which identify all the wrong solutions that have been given to you as input. Um, so at least identify as many of them as possible, and of course your tests should pass. I mean, the correct solution should pass all your tests. Every solution that's wrong should fail on at least one of your tests. That's kind of the ultimate goal. So this is not very different from what you would do during a challenge phase of a top coder competition, for instance, right? So the idea is, can you think about ways to break programs with clever tests? And so this kind of tool, Exemplar, is very useful for teaching people about testing and to really think about test coverage and writing good test suits and things like that. Of course, if you have ever actually um, created a CP contest, either for your college or if you plan to become a problem author or whatever, usually most CP problems are actually set by a team of at least 2 or 3 people, usually at least two, because there's a setter and a tester. And it's good to sort of have two different people doing that, just because it gives you additional sort of sanity checks. And the goal of the tester is to really ensure that, I mean, you have to be really creative, right? Because you have to imagine all kinds of corner cases that people could leave out, all kinds of mistakes that contestants may make, and things like that. And so therefore, that's a very important aspect of creating problems. And tools like Exemplar allow people to practice this in their regular labs, in their regular sort of classroom experience, which is great. So one of the things that Exemplar, I think, requires is this large number of uh, wrong solutions to a given problem. And so a couple of the recent papers about Exemplar is how do they generate these, solution suits, which will lead to interesting challenges with creating tests. I think it may be interesting for people to explore, all the data that comes out of a CP contest for creating systems like this. I think it could be a great sort of a data source, and that is something that I know at least some groups are looking into. There's also a lot of work on tools like GitHub Copilot or Replit Ghostwriter. These are AI systems that can, basically, given the correct set of prompts, they can essentially complete it. So, you can, in VS Code or whatever your favorite editor is, if you have something like Copilot running in the background or installed, you can just start writing something like define GCD A comma B or whatever, int A, int B, whatever the syntax of your language is, and Copilot will just complete it for you and will populate the body of the function and implement the whole thing for you, because it knows from the whole GitHub repository database, it knows what to do, right? So now a lot of people are just working on how to prompt Copilot in a good way so that you can get it to perform for you optimally. But of course, for somebody in education who is trying to teach classes and give assignments, this is a complete nightmare, because if Copilot does everything, then when are the students going to solve these assignments? So I think a lot of people are also looking to like the CP style of testing algorithms competency as a way to sort of beat Copilot, because these are usually new problems that even Copilot will not know how to solve. So there is definitely increasing interest in competitive programming problems and the whole way that it is done from people in CS education research. So that's I wanted to quickly point at that. And then I think, like we said at the start in the introduction, that puzzles is the heart of competitive programming. It is true that most CP problems have a very strong puzzle-like flavor. And I don't know how many of you follow Three Blue One Brown, which is this amazing YouTube channel that talks about like math stuff, and often there are videos about puzzles. So this is one of my favorites. It's about this chessboard puzzle, and if you've not seen it, you should totally check it out. Try to not spoil it by watching the whole thing, because it's a really interesting puzzle. We don't have enough time to again get into the specifics, but the broader point I wanted to make here is that the puzzle itself is interesting. It sounds very artificial. There's this big story about a prisoner and a jailer, in fact two prisoners, and they have to communicate and come up with a strategy to do a task that seems completely bizarre. And at some point, some of you may be wondering, okay, all this is good fun, but do these puzzles have any larger goal? And can we or do we just do them for fun? And I think it's perfectly all right to say that you work through puzzles for fun, because it sort of keeps you sharp. It lets you practice, you know, uh, applying ideas in creative ways, and all of that. I think is just generally good for solving important problems whenever you come across them. But actually some puzzles also have much more direct connections with real world problems. So shortly after posting this video about the impossible chessboard puzzle, there was a follow-up video about Hamming codes, which are error correcting codes, which are extremely important for for all kinds of applications today. And the heart of it are ideas which are very similar to the kind of ideas that come up in the chessboard puzzle. So this is just one example. There are many, many. In fact, I wanted to show you a card trick. Again, I think we are almost on the hour, so I'll just tell you how this trick works. I don't know how feasible it will be to do it interactively, but this is a popular card trick called the 27 card trick. And the idea is that you ask somebody to, choose a card from here. So let's say we pick the king of clubs. So you just ask in which row it is. You, as the magician, ask in which row is the card. You don't know it's the king of clubs. So this person says it's in row 2. And now the cards have been shuffled. So now you say that it's in row 1. And now the cards have been shuffled again. And I think we were looking at the king of clubs. It's again in row 1. And now you're able to identify that it was actually the king of clubs. What's happening behind the scenes of this card trick is basically that once somebody tells you that it's in a particular row, you know that you have reduced your search space from 27 cards to 9 cards. So then you shuffle the cards around in a way that looks random, but what you're doing is taking those 9 cards and distributing them 3 each along the 3 different rows. The other cards you don't even care. And then when somebody points to, let's say, the first row, then you know that your search space is down to 3. And then you can distribute those 3 cards, 1 card per row, and that'll give you the final answer. So essentially, with every probe, you are reducing the search space by 1/3. And this may remind you of something like, say, binary search, right? So this is, you can think of it as ternary search because you are dividing, you're getting rid of 2/3 of the search space in every step. So although it looks like a card trick and it looks like a puzzle to figure out what's going on, the idea of binary and ternary search is absolutely fundamental to computer science and is used everywhere to do things efficiently, either as a part of a larger algorithm or a more sophisticated idea or just by itself. So I would say do puzzles for fun by all means, but if anybody asks you, you can also say that they can really be very useful. Okay, so on that
Excuse
note,
me.
I think I will stop. Thanks so much, and I hope I didn't run too much over time.
Thank you very much for the talk, ma'am. On behalf of the Assistant Coding Club, I would like to thank you for taking time off your busy schedule to enlighten and guide us on the path of competitive programming. The club looks forward to interacting more with you in the future. We would also like to thank Chitra Babu ma'am and Pala sir for making this event possible.
Yeah, absolutely. So I think this was slotted up for an hour, so I don't want to keep you, but I will say that if you have any questions, please feel free to reach out to me. My website is neeldhara.com that has the email address. I'm happy to interact more with anyone if they would like to one-on-one. I also have a course on NPTEL on competitive programming, so if you're interested in that, you might want to take it up. Some of you, but I do know that there has been interest from SSN College. So for those of you who may have already taken up the course, thank you so much. And thanks again for having me. And I look forward to keeping in touch with all of you. So yeah, thanks once again.
Thank you very much, ma'am.